one of the scariest places many can think of, the most wonderful to others, a place we haven't really visited beyond low Earth orbit for over 30 years. This is space. We don't exactly know how many stars there are in the universe. We can make estimates though, but these estimations are limited by the technology available to us today. Once new and better technology comes along, we'll be able to see even further out into space and discover even more stars, and thus the estimated star count increases. But it's quite beautiful though, isn't it? Just seemingly flying among the stars like this, at 100 megaparsecs per second. Except what you're seeing is not stars. These are galaxies, each galaxy containing millions, billions and even trillions of stars, most of which have their own planetary system with celestial bodies circling around. It truly gives you a sense of scale. How small we are, just a tiny speck in this sea of space dust. But as we can't know for certain how many stars and/or galaxies there are, let's take what we do know. And what we do know is that the observable universe contains at least 170 billion galaxies. We also know that our own average-sized galaxy, the Milky Way, has around 400 billion stars, so we can use that as a template. Now take 170 billion galaxies, multiply that with 400 billion stars, and we get the number 68 sextillion possible stars in the cosmos. Black holes. One of the most mysterious objects in the universe. Everything about them is just taken to the extreme in one way or another. They twist and bend space and time around them. Some have been found to rotate close to half the speed of light. They can be smaller than an atom or billions of times more massive than the largest known star. They even stop time. And if you wanted to destroy one, well, you can't. Whatever you throw at it will just be added to its mass and energy. Lasers, bullets, nuclear warheads, a unicorn, the Avengers, a star, a galaxy, Google+, another black hole. It would all just be consumed. But they're not completely indestructible though. They have one sworn enemy, one weakness: time. Wait long enough and eventually black holes evaporate because of something called Hawking radiation. This radiation causes the black hole to slowly lose mass over long periods of time. In part 1, I talked about the largest known galaxy in the observable universe, IC 1101, which is estimated to contain about 100 trillion stars. On the other side of the spectrum, the smallest galaxy found so far is called Segway 2 and only contains the tiny amount of 1,000 stars. The galaxy is also very, very old. The stars are believed to have formed more than 12 billion years ago, meaning that they were most likely among the first stars to have formed in the universe. In 2023, we might have a reality TV show on Mars. This is if the Mars One project is successful. Mars One is an organization with the goal of establishing a permanent colony on Mars. Only last year, people could apply to be one of the colonists to go there and thus leaving Earth forever to spend the rest of their lives on Mars. Over 200,000 people applied, but only 4 carefully selected individuals will be sent there in 2023, and every step of the crew's journey will be documented. And every 2 years, 4 additional colonists will be sent to Mars, and the colonies plan to expand this way over time. The ISS is pretty cool and all, but you know what would be even more awesome? A big ass fucking donut in space. No, I'm not even kidding here. That's at least what NASA thought would be a great idea back in 1975 when it was proposed to build a donut-shaped space station codenamed Stanford Taurus that would simulate artificial gravity and, almost like a little side note, support over 10,000 people. So of course they soon realized that going from zero manned space stations to a space city of 10,000 people was kind of a big step. Not to mention that it would take decades to get the material needed up there and more money than the whole economy of the United States. After NASA had successfully landed on the moon in 1969 with Apollo 11, several other Apollo missions took place all the way up to the final Apollo 17 mission before the program was cancelled. But that was actually not the plan. NASA had already prepared for Apollo 18, 19 and 20 missions. After Apollo 17, the plan was to, get this, colonize the moon, with 6 people living on the lunar surface for up to 180 days. But the reason this never took place is, of course, almost as always, money. A lot of you have probably, at some point at least, imagined what it would be like to be living in space. And well, it would be pretty fucking uncomfortable. First of all, you'd have to work out every single day for several hours to prevent your bones and muscles from shrinking due to the lack of gravity. This includes your heart, which would become weaker and smaller due to the same effect. You'd also become taller in a very painful way, as your intervertebral discs that cushion your spine would slowly drift away. You would see bright light flashes as you close your eyes because of the radiation that the Earth's atmosphere normally filters out. You will have trouble tasting things and feeling sick because of fluids in your body acting really weird in 0G. Bacteria also starts going crazy and becomes much more effective, while your immune system starts weakening. Basically, if you get sick, you can die. And as if that weren't enough reasons to not want to live in space, you can't have sex either. Like ever. Without gravity, your blood pressure decreases, so for guys it just becomes impossible to get it up. A common myth about space that's often seen in movies and TV series is that asteroid fields are full of asteroids very close together, and traveling through one is next to impossible, or at least very dangerous. However, this isn't true at all. Space is gigantic, and asteroid fields are no different, where the flying chunks of rocks are separated by huge distances. In fact, when NASA sent a probe through the asteroid belts in our own solar system, it had a chance of 1 in a billion to actually get hit by an asteroid. A dream of many, including myself I must say, is the prospect of someday being able to visit other stars, other planets, and maybe, just maybe, we'll find that we're not alone in this universe. But with the knowledge we have today, just how likely is that? Will we ever be able to take a quick road trip to Kepler 22b and check in at the local hotel for 50 space coins? Well, we can never know for certain, but unfortunately the chances of that seem very slim at best. The biggest issue is that to get anywhere on such a large scale, we need technology that can somehow overcome the light barrier. And when I say overcome, I mean we really need to go much faster than the speed of light. The closest star, Alpha Centauri, is only 4.2 light years away, meaning it would take 4.2 years to get there if we could travel at the speed of light. And I'm not even accounting for how long it would take to start and slow down during this journey, time dilation, and the fact that it would take another 4.2 years if we wanted to go back or send some sort of message to people back on Earth. And with the current understanding we have of the universe, faster than light travel just isn't possible, at least not in the traditional sense. We have not observed anything going faster than the speed of light. So what options do we have? Well, believe it or not, but there is in fact a slight possibility that a version of the warp drive from Star Trek could become a reality sometime in the future. It's called the Alcubierre drive, and the way it works in theory is that it wouldn't move the ship at all, but instead moves and bends the space around the ship, and thus overcoming the light barrier without breaking any physical laws. Basically, instead of moving across a plane, you move parts of the plane to take you across it. But as you can understand, developing a technology that could bend space and time itself is not an easy task, if even possible. But at the moment, if we want to go faster than the speed of light, while also overcoming complicated issues such as time travel, the theoretical Alcubierre drive seemed to be our best bet.